So I had promised to do a Visual Studio Code debugging video for a while, I think. And I haven't really done anything productive besides like gaming videos and stuff. So I kind of want to get back into the swing of things. Now, this video is going to be a little bit different because we are going to be going over debugging stuff, but I'm doing this live. Normally what I do is I record footage and then I do voiceover. Unscripted voiceover, but still voiceover. I'm doing this totally live, and trying to write code or do anything development related live while there's a camera going and trying to kind of formulate your thoughts is really difficult. So this video will either suck or it will be all right. So hopefully we can make it through it and maybe you'll learn something. So you're looking at this, and if you're not familiar with Ruby, this may look really weird. We're not going to focus on the fact that it's Ruby or the language at all, or how not so good the code is. This is a little game that I made, I don't know, a few months ago, just kind of playing around with Ruby, because I actually like Ruby. I know a lot of people hate it. I like Ruby. And the framework that I'm using is called Gosu. And I think that it might be deprecated at this point, but it was really quick and easy to set up this game. It's only got a couple classes, and you don't need to debug it. I didn't debug it when I was writing it, but I think that this will be a really interesting specimen to show you guys how debugging works and kind of what is happening on the inside of a program while you debug it. So in Visual Studio Code, there's a super awesome debugger. I think when I talked about Visual Studio Code before, I briefly talked about debugging. I think I said that it's mystical and magical and wonderful, and I'll talk about it later, and here we are talking about it. So when you go to the tab, which is here, it's the little like bug thing, you'll notice this like side pane with like nothing in it, and there's not supposed to be anything in it. This gets filled up as your program is running. You have your call stack, you have your watch, and you've got your variables. We'll get into those in a little bit. So what you need to do is you need to select your debug file. So because this is Ruby, and Ruby is not necessarily native to Visual Studio Code, I had to get some extensions. So I've got the actual Ruby extension, which provides the actual language support, but also debugging. So if I do something like, hell, what's a good, puts is a pretty standard example. Really? You're not gonna, I guess it'd be puts. Wow, okay. Well, that was a shitty example. Okay, this is completely failing. Well, at any rate, this is supposed to add IntelliSense. I don't know why it's not working. I'm not that worried about it. But this plugin also includes debugging support. I also brought in Rubocop because Rubocop provides static analysis and linting, which I like. We could talk about that another time. So at any rate, if you want to debug something like Python, you'll need to look for the Python extension, which is here. If you want to do something like, I don't know, Lua is another interpreted language, you can do that. These plugins aren't nearly as powerful. Python is probably pretty damn close to being natively supported by Visual Studio Code. You have 375,000 installs, whereas Ruby you only have, I guess, 43,000. Wow, that's a huge difference. Anyways, the point is that whatever language you plan on debugging, you have to have the extension for. C# is no different. You have to have the extension for that. So once you have the extension, you need to create a, I guess, a debug file or maybe a configuration file. So I've already done this. When you go to run it the first time, it'll prompt you and say, hey, you need to go ahead and create this file. So it's going to be a JSON file. And this is a skeleton that was generated for me. With JavaScript, it would be the same. With Python, it would be the same. I mean, it'd be similar. Obviously, this is a Rails server thing. This is not a Rails app. It generated this because Rails is very commonly used for Ruby stuff. So also, our Debug Ide, that's a Ruby gem I had to install. Again, if you're debugging this with, I bet Python probably has, they use pip to pull down an IDE or debugging extension. I'm not really sure. If you're into Python, you probably know more about that than I do already. So yeah. All right. So this is the section we're going to be focusing on as far as Ruby is concerned, because this is just like debug. It says right here, debug local file. We're not running this on Rails. We're not running this on like Rack or RSpec is a test framework. We're not doing any of that. We're just debugging a local file. So the type is, I think, the command that's run. So in this case, If we go to Rails, is it Rails? No, it's Ruby. Okay, so the type is probably the language, I think. There's very little information. Type of configuration. Well, what the hell does that mean? So I guess it means that probably the type of file, maybe the language or something. Request is launch. Another type of request is attach. I'm not sure how attach works. I think that that's useful when you're debugging Node applications, or specifically something like Angular or Ember. I'm not really sure. I've only really used launch because I debug local files. CWD is the absolute path of where we're actually working. So in this case, all of my files are located in lib. If I go back to the root directory, I have spec, which is where the tests are, and then this is the root directory, so I've got my license information and stuff there. But the actual files are in the lib directory. Ideally, you'd also have a bin directory, but again, that kind of depends on what you're working with. The program is I guess it could be the executable, it could be the main method. Most interpreted languages don't really have a main method per se. A lot of times people call it just like main.rb, main.vala, main.py, whatever. So I called main.ruby, and that is located here. So there's not much happening here. All that happens is you just do ruby main, which is what the debugger does, and our application pops up. So here we are. Where'd our JSON file go? It closed it. That was weird. Stay open. So I had to make two changes here. Before, it was just workspace root, which is the root directory of where the application actually starts. So the way I got here is I went to open folder, and then I opened the folder, the absolute path of where this application resides, which is called zombie run. So the absolute path is actually in my source folder, but workspace root is referring to the actual location of where you opened this. So the program, again, is where it starts, the main method, so to speak. In this case, mine is main.rb. So if I left this the same, like if I didn't change this, because remember I had to do lib because that's where all my files are. If I just left that as workspace root, workspace root, what would happen is I would hit the go button to start debugging, and it would crash in a different location. Line is too long. Oh, that's my linter. Okay, so this was kind of weird. So what I had here just a second ago, this is probably a little confusing. So this here is the integrated terminal. This is built into Visual Studio Code. So when you go to run the debugger, it does not dump the debug information into the terminal. So notice how I click this button, nothing happened, there's no information. That's because the debugger uses its own console, which you can access here. And then there is another console for static analysis that is down here. So that is a little confusing. So let's go back to the debug console. And it says cannot open file, assets, images, grass texture. So when I first hit this error message, I was really confused because like this file is here. Obviously it's there. I mean, we just saw the game run a second ago. So what the hell is wrong? If I run it from the terminal, obviously the game will work. So there's our grass texture. So obviously it's working. So what is this talking about? So the problem is that this CWD is running in the workspace root. And if you remember the workspace root, control, okay, I got to remember that hotkey. So the workspace root is all the way back here. So when it tries to find the assets folder, it can't find it. So with that said, we had to add /lib. So the CWD, which I'm still not sure, something working directory, change working directory. I don't know what the C stands for, but we had to change this to the actual working directory, which is lib. So now when we debug it, we'll see the application. And here we are. So that's how to get started, and that is really the first step. Well, maybe the second step. The first step is getting all the prerequisites. So if you're debugging with Python, and I'm using Python as an example because it's probably the second or third most popular language used with Visual Studio Code, you need to make sure you have the Python extension, and you need to make sure that you have all of the pips or whatever those are called to make sure that you can actually debug. So once you've got all the prerequisites, you got to set up your launch.json file, which is, where is that actually? Oh, it's in the VS Code folder, which is created by Visual Studio Code. This probably isn't something you want to check in. So if you're using Git, you would want to add to your git ignore to ignore this entire folder if it doesn't already. But if you're not using version control or you don't care, then obviously don't worry about that. So now let's talk about the actual debugging. This is where things get interesting. So let's open up a couple files. Game window has some interesting stuff. Also, if you're analyzing and judging my code, this is not good code, and I did not do good things with it. The comments suck, and there's a lot of stuff that shouldn't be in here. Most of these functions get called recursively over and over and over again, and that's not good, especially for performance. But I think this is the second game that I've ever written, and it's very interesting, but I am certainly no game developer. So both of these classes have a lot of logic in them. So there's a lot of things that we can debug in here. So this is probably, getting the distance is interesting, though I can't remember where I did that. Oh, here it is, right here, where we draw. Okay, so let's put a breakpoint here first. So this line of code is saying close if the zombie object, which is referred to up here, if the zombie's object's distance is less than 75. I think it's 75 pixels, I think. So let's go ahead and run that. Let's go ahead and move this actually off to the side first. And when the window pops up, I can move it over here and you can kind of see what's going on. So we'll go over to the debugger and kick this thing off. So here's our application. Notice how nothing is rendered yet. That's because in my crappy code, the draw function, actually I don't think this is, I think it's supposed to happen. The draw gets called 60 times a second, so that's 60 frames a second. So this function gets called 60 times a second. So before anything is even rendered, this guy is getting called. So we want to leave the breakpoint there. I probably should have explained how to set them. You basically click here. There, I'm setting breakpoints all over the place. Pretty self-explanatory. So when you run your code, the code will go through procedurally, and then it will find a breakpoint, and everything will stop. So now see over here on the left-hand side, all this stuff is populated. So we've got our variables. So here's our zombie object, and he's got all this information. This is populated through the constructor when I think the game window is created. So obviously the zombie doesn't exist yet, but he exists in memory, if that makes sense. He's got an object, goes to image object. I'm kind of surprised it doesn't give us the path of the image, but that might be somewhere else, I'm not sure. A lot of this stuff I didn't set, like font, is by default, but it gets brought along because it is a variable or a property or attribute, as Ruby calls them, on the game window object. I'm not sure. We've got our global variables. Global probably isn't the right word, I don't think, but that's what they call it. A lot of this stuff is undefined and not important to you while you're debugging unless you have a very good reason of going in here. So if you're looking at something that's JavaScript related, there's going to be a ton of just shit in here, and you won't be interested in it unless you know what you're looking for. So generally, the global variable scope here, you don't want to worry about. There's local, and then with JavaScript, there might be like something like block. But with Ruby, I believe you're only going to see local and global, and I assume Python would be the same. So I don't have any watches, and watches are kind of an advanced topic that I don't even personally use as a professional developer very often. You have to have a good reason to use it, and I don't know. I've seen guys use it. I don't really have a use for it. If you really want me to talk about it sometime, I can, but we're just going to skip over that right now. The call stack is really interesting, especially if you're trying to find bugs. It tells you what functions are being called up to the point that you get to that breakpoint. So this is a pretty linear application. There's not a lot of logic. You start at the game window and you kind of work your way down. And the draw function, I think it is called constantly. Again, 60 frames a second implicitly, I think. So the call stack is going to basically look the same every time we look at it. So we've got our window, and we've got, I don't know what these swig patches are. I didn't write them. This is internal to Gosu. There's a lot of them, though. That's interesting. So the window show, I believe, is what the function that gets called 60 times. So let's just go ahead and continue. And each time we hit F5, it's going to move a frame. See? Just like that. Now, this probably doesn't look very interesting, but if you're looking for something, like if you're trying to figure out how to calculate something, and you need this, well, I guess you can't see the mouse. If you need the zombie's absolute position without having to do some kind of crappy hack, like you could do, I could do something like, what's my angle? This is called poor man's debugging. I don't think Ruby will accept that. No, it won't. I have to restart the application. So what I did here was have the value of angle, which is here, and it's recalculated each time this is run, be put to the console. So it's going to print this to the console. So if you didn't have a built-in debugger, you could see what the angle of the player is by using this expression here. So if we stop debugging and we run the debugger again because I removed that breakpoint, you'll see, oh, you know what? Actually, no, it won't. I got to put it here. You'll see the console be filled up with the value of that. See? There you go. Whoops. And then you could also print that to a log if you wanted to save it for some reason. So there's your poor man's debugging. Now let's go ahead and get rid of this guy. And we can put a breakpoint here on angle, run the debugger, and again, it's going to immediately break when the application starts, which is fine. We'll move him over, and we'll find our variable, which is angle right here. This is actually going to be kind of hard because I can't move my guy because he's constantly breaking. And I don't think with Ruby you can just drop a breakpoint in. Let's find out. So my angle is going to remain 0. So let's see the best way of doing this. So I removed the breakpoint, and now I'm going to hit continue. Now we're just kind of driving. Let's keep the zombie from getting to us, huh? Okay, there, it did work. How about that? So we dropped him in, and let's go to the angle. There you go. Instead of it being 0, which is obviously straight up, it's 276 and change. So there you go. This is very basic debugging. Another thing that you can do with debugging is instead of hitting F5 or continue, which is continue the application, you can do things like step over, step into, and step out. And I know those words make absolutely no sense, but the most important one is F10, which is step over. It's step over. And what that'll do is it'll move execution to the next line. So if I hit F10, pow, now I'm on the next line. I hit F10 again, pow, I'm on the next line. Now, step over, oh hell, well, that's what it does. What step into and step over does is if you hit a function, like, let's see if we can get it to hit a function. Nope, we're not there yet. Oh no, now we're in Gosu. That's not where we wanted to go. Accelerate. Okay, so accelerate is a function right here. So step over would move the execution over this function and move us to the next line, which is here. So let's go ahead and do that. Pow. So it executed all the code in this function and moved us to the next line. So it stepped over this function. So let's go back to that function, assuming we don't die. Okay, so let's pretend that I want to debug something within this function. you would step into. So you'd hit F11, and now we're in this function. And then let's say that you're halfway through this function and you say, okay, I already have what I need. I want to get the hell out of this thing. You would step out, which I don't do very often. So we'll just step out, and now we're all the way down here. So we've stepped out of those two functions, and we're already back here. And I think that that wraps up debugging in a nutshell. I could go a lot deeper, but I think that this video will give you kind of the general idea of how debugging works, when you would want to use it, and kind of how to get started. Again, I'm using Ruby here, and Ruby may or may not be the best example. I'm inclined to believe that it's probably not the best example. You'll probably want to use Visual Studio Code with something like Python or JavaScript or something. And setting those languages up to do debugging is probably slightly different, but all the same after steps, post steps as it were, they all still apply. Step in, step out, the call stack, variables, and watches if you want to use those. Those are all the same. Just getting it set up and started is a little bit different. So yeah, that'll wrap this video up. Doing it live wasn't too bad. Kind of getting through the beginning of the video was a little bit tough, but once we get rolling, it's not too bad. So yeah, that's it. Hope you enjoyed it. Let me know what you guys think in the comments, and leave me a like, subscribe, and all that jazz. And definitely let me know how much you guys want to see new programming videos. I've been kind of putting them off. They take a little effort, especially if I'm recording the footage up front and then doing voiceovers afterwards. They take a pretty fair amount of effort to do. So if you like this format better, let me know. If you like the other format better, definitely let me know. And yeah, that's it. Thanks for watching.